Welcome to section 4.2 of college algebra. You'll be happy to know that I think this section is going to go quicker than the inverse function section, which had a lot in it. So up to this point, we can basically solve any function that we want that has x's to a power. Like if you have some crazy function like x to the 3 minus 2x squared plus 7x minus 9 equals 0, given enough time with synthetic division, you can find all the roots of that function and kind of sketch what the graph of it looks like. Even if you have x to the 98 power followed by 97 more terms, it would take forever, but in theory, you could graph it and see what it looks like. So that's nice. That should make you feel good. That's pretty powerful. And so now I'm going to ask you the question, well, what happens if we make x be the exponent? Because if you remember, the polynomial always had x to some power. But what we're going to do now is we're going to make x the exponent. And so we're going to learn some new tools on how to deal with that. When x is an exponent, that's called an exponential function or an exponential equation. In other words, the unknown is the exponent. So let's think about how we would deal with that. Say we have the function f of x is equal to 3 to the x power. Well, how would we evaluate that for different values? Let's find f of 2. F of 2 would equal 3 to the 2 power. Easy as that. Just 2 is the number we're plugging in. Let's see what the output is. We take 3 squared, which you'll remember is 3 times 3, which of course is equal to 9. So f of 2 is equal to 9. You can also do that on your calculator if you want. On my calculator, I have y to the x. That's the exponent button. So I type, well, you notice I have a square button right here. That's x squared. If I just do 3 squared, it goes straight to 9. I can also do the yx button. So in that case, I type in 3 first, to the 2 power, and you notice I get 9 again. So there's various ways to get there on your calculator. Let's do to the 4th power. So f of 4 would equal 3 to the 4th. Okay, so as you know, that would equal 3 times itself 4 times. This is going to get big quickly. That's why it's called exponential. So that's going to equal 9 times 9, which is 81. And on my calculator, I don't have to the 4th button, so I need to use the y to the x calculate button. So 3, that's the base, to the 4th power equals 81, which is the same answer I got right there. So remember, this number is called the base. This number is called the exponent. And the entire thing is called an exponential function. So that's the vocabulary you need to know. And you'll hear me use those words a lot, so make sure you have those in your head. Now to do f to the 2.68, I pretty much have to use the calculator. So luckily we can do that. So you can take it to a decimal. So 3 to the 2.68 equals 18 point, I'm going to round off, let's see, let's say that that's equal to 18.99699, or I'll add in the 7 and then I'll round down. So there's what 3 to the 2.68 is equal to. What about f to the negative 1? So f to the negative 1 equals 3 to the negative 1. And what's that equal to? Remember that if we take something to the negative exponent, it flips it. It makes it its reciprocal. So this is actually equal to a third. So that's kind of tricky. So 3 to the negative 1 is equal to a third. Let's see if the calculator verifies that. Let's take 3 to the 1, but then I'm going to hit the minus button to make it negative. And let's see what I get. Notice I get 0.333333, which as you know, hopefully is the same as 1/3. So the calculator still verifies it. Well, what would 3 to the negative 4 be? That would be f to the negative 4. Well, I know what 3 to the 4 is. That's 81. So 3 to the negative 4 would be 1 over 3 to the 4, or 1 over 81. Finally, what would f to the 0 be? This would be 3 to the 0, because our function was 3 to the x. All of these are for 3 to the x. So 3 to the 0, do you remember what anything to the 0 power is equal to? That's something you really need to know. anything to the 0 power is equal to 1. So that's how you would evaluate this function for various values of 3. Pretty easy. One thing to notice how all of my outputs were positive. Do you see that? Even if I plugged in a negative or 0 or a decimal, notice that all of the outputs were positive. That's important. So if I have 3 to something, no matter what I plug in for x, it's always going to be positive if 3 is positive. So that's something to keep in mind. Why don't you go ahead and pause the video and try to find all of these various values for 5 to the x. Pause the video now and see if you can get them, and then I'm just going to write down the answers. All right, here we go. Hopefully you paused the video and you found all of these numbers for 5 to the x. So let's go through it really quickly. F of 2 would be 5 squared, which equals 25. 5 to the 4 would equal 5 times 5 times 5 times 5, which would be 25 squared, which I believe is 625. It is. So that is 625. I have to use the calculator for this one. 5 to the 2.68. That equals 74.686. So what would 5 to the negative 1 be? Well, remember, that would be equal to 1 over 5 to the positive 1. Okay, you just flip it. And that would be equal to 0.2, because 1 divided by 5 is 0.2. How about f to the negative 4? That would be 5 to the negative 4, because we're plugging in negative 4 into x, into our function. So it would be 5 to the negative 4, which equals 1 over 5 to the 4. And so that would equal 1 over 5 to the 4, which I already figured out was 625. Finally, what would f of x, f of 0, if we plug in a 0 for x, we would get 5 to the 0. And remember, anything to the 0 is equal to 1. Hopefully you're getting the idea on this. Let's do one last example before we wrap this video up. Here's our function. You notice this time we have a fraction that's all being taken to that x. So 2 over 7 to the x. So what would f of 3 be? F of 3 would equal 2 over 7 to the 3. Now, I'm going to show you how to do this without a calculator and then with a calculator. Remember that this is the same as 2 over 7 times 2 over 7 times 2 over 7. That's what that means with the exponent of 3. So 2 times 2 times 2 is 2 to the third. 7 times 7 times 7 is 7 to the third. So you can kind of, it's not really the distributive property, but you give the power to the numerator and the denominator for this reason. So this would equal 2 to the 3, which is 8, over 7 to the 3. Let's see what that is. 7 times 7 times 7 is 343. So the answer should be 8 over 343. And let's go ahead and see what that is. 0.02332. Let's put that off in the corner for a second. So 0.2332 and then a few more decimals. So now let's see if we can do this with the calculator. So let's go all the way back to the original. Here's what I would do. I would first put 2 divided by 7 into my calculator and then hit enter. So there's 2 divided by 7 up there. Now I would take it to the third power. So now I would hit this button, the exponent button, and take it to the third power. And look, I get 0.2332 blah, 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 which is the same thing as 8 divided by 343. So hopefully that makes sense to you. That's how to do it on your own or with the calculator. To do this one, I'm pretty much going to have to use the calculator because it's 4.501. So again, let's do that with the calculator. Put in 2 divided by 7 to the 4.501 power. So let's clear the calculator. First, type in 2 divided by 7, then hit enter, and you get 2 divided by 7. Now hit your exponent button. And by the way, on a lot of your calculators, the exponent button might look like this. It looks like a caret. So you can see on my keyboard, if I can pull my keyboard over, oops. Do you see the button over 6? It's kind of a caret right there. that's what it might look like on your calculator. So if you don't have y to the x, or maybe it's sometimes a to the b or a to the c or something, that caret button right there might be what your calculator button is. So let's do 2 to the 7 to the 4.501 power. I already typed in 2 divided by 7 and hit enter. Now I hit my exponent button, and I'm going to type in 4.501 equals, and you get the answer 0.003557. It's approximately, I should put approximate signs here, approximately equal to that. Now notice that this number is smaller than this number. Even though we took it to a higher power, instead of 3, we took it to 4.501, we actually got smaller. So how could that possibly be? In our other examples, the numbers got bigger. Okay, this is really important. In our other examples, when we had 3 and 5, the number got bigger as the exponent got bigger. So why, when we did 2 over 7, is the number getting smaller? This is an important idea I'll talk about in the next video. If this base is bigger than 1, it's exponential growth and it's going to blow up. But if it's a fraction, if it's between 0 and 1, well, then the more this exponent goes up, you're doing a fraction times a fraction times a fraction times a fraction, which is going to result in the number getting smaller. So let's look at that more in detail in the next video. I'll see you there.